Okay, so I have a very interesting math word problem here for you. Now, a lot of you may not have studied the math topic that is involved in solving this particular problem, but don't let that worry you. This is not that difficult. And if you stick with me for a few minutes, you're definitely going to learn something very powerful in mathematics. But let me go ahead and read you the problem here first. It is the following. A boat is going 5 knots due east. Now, the current it's in, so maybe some sort of river or whatnot, is 5 knots due south. So the question is the following. What's the boat's actual speed and direction? Because obviously the boat is being influenced, its speed and direction is being influenced by the current. Now, even if you don't know what to do here, mathematically speaking, see if you can kind of sketch out what's going on here and just guesstimate. What do you think the boat, its actual speed and direction may be? Okay, so just give it some sort of reasonable guess. But if you know how to do this, either way, whether you have the actual answer or if you just want to take a wild guess, go ahead and put that into the comment section. I'm going to show you the correct answer in just 1 second. Then I'm going to thoroughly explain this problem step by step in a nice, easy way. Because the topic we're dealing with here is, usually taught at a little bit more advanced levels, but I'm going to make it very easy to understand. Okay, but before we get going, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if you like this video, then we'll hit that like button and that subscribe button, as that definitely helps me out. Okay, so again, even if you don't know what to do here, at least take some sort of guess. But let's go ahead and take a look at the actual answer right here. And the actual answer is the following. Okay, so the speed of the boat is approximately 7.07 knots, and its direction would be 135 degrees. All right, now some of you are like, oh my goodness, I have no idea what's going on here. I'm totally lost. Well, listen, you're not going to be lost for long, but if you got this right, we must celebrate by giving you a nice little happy face and A plus a 100% and multiple stars so you can brag to your friends and family that indeed you are a certified professional expert in the area of vectors. Okay, and that's what we're going to be talking about here, vectors. And when I think of vectors, I actually think of a very funny movie. At least it was funny to me. I think it goes back to 1980, 1979, something like that. The movie was Airplane. Okay, so some of you, well, most of you probably know the movie Airplane. But, anyways, there's a part in that movie where the person is saying something like, "What is the vector, Victor?" And asking this person, Victor, what is the vector? But if you watch, if you're kind of a movie buff, you like to watch a lot of movies when there's, like maybe military things going on or aircraft especially, you'll hear this word quite frequently. What's the vector? Vector this, vector that. So this word is fairly common, and I'm going to totally explain it in just 1 second. Now let's go ahead and take a look at our problem here, and we have this boat and it's going 5 knots due east. Now, I didn't write in due east here because I wanted to kind of shorten this word problem, but due east means it's actually going totally perfectly eastbound, and the current is going southbound. Now, this word problem actually is near and dear to my heart because in a former life, I actually served as a U.S. Navy navigator. I was actually what they call a surface warfare officer, U.S. Navy surface warfare officer. So yeah, I kind of drove the ship, commanded the ship, but actually one of my responsibilities on one of my tours was to navigate a very, very important ship. I was the navigator. So, at that time I knew how to navigate celestially and everything else, but when we used to bring in ships in and out of port, you're definitely considering the current and what we call set and drift, because this has to be measured because you're going this direction, but the current's pushing this direction. You're not actually going the direction you like to go. You have to calculate, or you have to, consider the current and the wind and everything else when you're trying to drive a ship. But anyways, some of you may remember if you have subscribed for me. I also did two tours. I was in the United States Marine Corps as an enlisted person. Then I kept working, moving up, and I ended up as a U.S. Navy officer. But anyways, I really do, appreciate um, all my military experience. But anyways, I don't want to digress too much. But we have this word problem, and of course, we need to read the prompt 3 times. I kind of hopefully broke this prompt down in a way that everyone can understand. So the question again is, what is the boat's actual speed and direction? Because clearly the effect of the current is going to be pushing your boat, right? So we want to know, well, is it going to make it go faster? Is it going to make it go slower? And what is the specific direction? So with any math word problem, you want to model it. So how can we model this situation? Well, basically come up with some sort of sketch. I'm going to show you the sketch here, but I want to basically give you a hello, a welcome to the topic of vectors. Okay, so I'm going to show you the sketch here in a second, but say hello to vectors. Okay, and if your name is Victor, well, say hello to vectors, Victor. That's a little my attempt at trying to be funny. But a vector in mathematics, and this is the key, okay, this is really going to be the key to understanding this problem. A vector is something where we have speed and direction, okay, speed and direction, or we call magnitude and direction. Now, this doesn't make a lot of sense here, so let me go ahead and give you some examples of vectors. All right, so here are some examples of vectors. Now, vectors are expressed typically as arrows. Okay, so there's a starting point. Okay, and then there is an arrow at the end. Okay, so this is the kind of the beginning, and then the arrow is pointing in the direction. Okay, where the this speed and direction is going. Now the length of the arrow represents the speed or magnitude of the situation. Okay, so for example, let's suppose we are talking about wind, right? So let's say we have wind gusting at 20 miles per hour due west, okay, which would also be 270 degrees. So our little arrow here is going to be pointing in the direction of 270 degrees west. Now, a 40-mile-an-hour wind is going to be double the size of this vector. So if this is 20, if we double it, this represents 40 miles per hour. And of course, we're talking about the same direction. So the arrow is pointing in the direction of the vector. Okay, so again, this would be a 40-mile-an-hour, for example, wind. And again, there is a starting point and a tip, okay, beginning and a tip to an arrow. All right, now I want to show you a couple other examples of vectors here, but let's kind of review the basic compass here and just how we read a compass, because if you don't know this, then you're going to be confused in this particular problem. All right, so we have north, south, east, and west. Pretty much everyone, understands that. The sun rises in the east and it sets in the west. But what we want to do in these type of problems, okay, you want to associate north, south, east, and west with compass headings. Okay, so we're talking about true north and true south, east, really true north. And the difference is 0 degrees. Just, not to digress too much, but here is our lovely world right here. So here is north and here is south. When you have a magnetic compass, okay, when you have a magnetic compass, the magnetic compass is not pointing towards where Santa Claus lives, true north. Your magnetic compass is actually pointing way over here towards Canada, somewhere up there. This is where all this iron ore deposit. And I got a kind of a little bit rusty on this, but basically you're not pointing towards actual true north, which is 0 degrees. Okay, so this is called magnetic north. So if you followed your magnetic compass, you would end up somewhere over here, okay, in north east Canada, if you will. So we have these things called variation, deviation to correct for this. So on ships, on aircraft, whatnot, you have gyro compasses that give you 0 degrees, perfect true north. Okay, so little tiny details because some of you might be saying, well, I have a boat, but on your boat, okay, you're going to have a compass, you're going to have a magnetic compass, and you're probably going to have a gyro compass, two different readings. All right, so now most of you are like, okay, Mr. YouTube Math Man, now I know more than I ever wanted to know about compass headings. Well, it's important that you understand this because if you do these type of math problems, you have to understand how to read a basic compass heading. All right, so north is going to be 0 degrees. It's also 360 degrees, but we're going to start at 0, and we're going to go round robin this way, okay? We're going to go clockwise, right? So east, right here, is 90 degrees. And if we continue on another 90 degrees, we have 180 degrees, which is south. And we continue on another 90 degrees, we end up at 270 degrees, which is due west. And then we finish up with another 90 degrees. We're back to north, which would be 360 degrees. But if you wanted to go due north, you wouldn't say, steer the ship 360 degrees or aircraft. It would be like 0 degrees. Now, let's kind of just look at this compass heading here real quick and get some other measurements down or get a feel for some things. So, for example, something like right here, this compass heading right here would be what? Well, this is 0, right? We're going this way. So this would be maybe something like 45 degrees. And right here would be like what? Well, maybe this would be 120 degrees, all right? Because it's got to be more than 90 and less than 180. And then something like right here could be maybe like, I don't know, 220 degrees, etc. Okay, so you, hopefully, this basic class on compass heading makes sense, but it's important to understand this because in this type of problem, if you don't have a good feel for compass headings, then you're going to be confused. Okay, so let's go ahead and actually sketch this out. And before I do that, actually, let me show you a few more examples. I'm kind of getting ahead of myself here. So this would be, let's say, more examples of vectors. So we got arrows. So this would be, for example, like 45 degrees. So remember our compass heading right here, this would be like 45 degrees. So look at this arrow. It's pointing like 45 degrees in this direction. Okay, so this could maybe be like 80 knots. This could represent an aircraft going like 80 knots at 45 degrees. And right here, we could have like another faster airplane going 160 knots at 130 degrees. Again, you're referencing our lovely compass headings here. So the actual direction of the arrow, okay, is important. All right, so now let's go ahead and continue on and talk about vector addition. Then I will show you this kind of sketch of our situation. It kind of represents our word problem. Now, this is the key here, all right? What the key to solving this problem is something called vector addition, vector addition. Now, this is not difficult, okay? And I'm going to explain it right now. So let's take a look at this white arrow. Let's suppose this represents some sort of jet aircraft, and we kind of just draw this out right here, flying, and it appears to be going, like, say, due east, right? So here's an airplane. Maybe it's going like 500 miles per hour. It's going from LA to New York City, something like that. And so the length of this arrow would represent 500 miles per hour, and the direction, the way we wrote the arrow, is eastbound, okay? Now, let's suppose there's a pretty good cross current of wind, okay? So let's say this wind is pushing, okay? Say some sort of, not jet stream, but let's say this airplane is being pushed by some sort of air current, and let's say this blue arrow represents that current. Now, this current is pushing on this airplane in a perpendicular manner because that's the way it appears, right? So right here it's 90 degrees. So if this is 500 right here, if this is 500 degrees, or I'm sorry, 500 miles per hour, what would be the speed of this current? Well, we just kind of have to look at that. We're like, oh, I don't know. Maybe this is like 100 miles per hour, which would be pretty crazy in terms of air current. But maybe it's like 80 miles per hour. Maybe it's a gust or something like that. So here is how vector addition works. This is how we get the actual speed of, let's say, the actual direction and speed of an aircraft, okay? Now, as our airplane is moving along this way and it's getting hit by this crosswind, what's going to happen with the airplane? Well, clearly the airplane isn't going to continue on its path like this. It's going to get pushed this way, right? We're talking about kind of common sense here, right? So here's my little lovely airplane. It's going to get pushed in this direction, and it's probably going to pick up a little bit of speed. Okay, so this wind is going to push it this way, and it's going to speed up the airplane a little bit. And this is what we call vector addition. All right, so here is how this works. So when we have two vectors, we can add them up. So we have the beginning of the first to and the tip is our first vector. So you take your second vector and you put the beginning of it at the tip of the first. Okay, so you can see here our air current here. I'm going to put the beginning of it at the tip of the first, and now I have the arrow of the second. All right, so basically you have an arrow like this and then another arrow like this. You always add vectors this way. Okay, so the beginning of the second vector is going to start at the tip of the first. Then to add those vectors, it's going to be the tip of the first to the beginning of the first to the tip of the second. So this is what we call the resultant vector. Okay, we start right here from the beginning, okay, of that first vector, and it goes to the tip of that second vector. And this, the length of this vector right here, is this actual speed. Okay, this represents the speed the airplane's going, and this angle right here is would be the actual angle or the direction the aircraft is going. Now, how we calculate this out, what math we need, well, this is what we're going to get into in a second. But typically, you can use some basic geometry, but in more interesting problems, you're going to use some trigonometry, right? So, vectors as a math topic is typically taught generally like maybe in algebra 2, but typically like in pre-calculus, any course where you're studying trigonometry, okay? But here's the thing, I know you're smart enough to understand this basic stuff, so I'm going to teach you exactly how we solve this particular problem. Okay, so needed to kind of get through all this because I know a lot of you probably don't remember vectors or never study them. And now let's go ahead and take a look at our problem. Okay, so here's a situation, and because we want to find the boat's actual speed and direction, we know, oh, I'm going to have to represent what's going on here using vectors. So now we can go ahead and sketch this out. All right, so here is our boat, for example, okay, and it's going due east. So our boat's going due east at 5 knots, and our current is going due south at 5 knots as well, right? So that's what it says. The boat is going 5 knots east or due east, and the current is going 5 knots due south. So we have to write this out. We'll just use some general compass headings here. So east is this way, south is this way. Due south and due east means perfectly east or south or west or whatever the case might be. All right, so if you're going due east and this current is due south, what you're forming here is a perpendicular angle, okay? And so what we have is in fact a right triangle. But the question here is, what is the boat's actual speed and direction? So if the current is pushing the boat's certainly not going to continue due east. It's going to go along this path right here, okay? And it's going to speed up a little bit. So the key to solving this problem is to figure out what this angle is going to be right there and what the distance of this right triangle is right there. That's going to be the actual speed, and this angle right here will be the direction, or will give us a hint into actually getting the correct compass heading, okay? All right, so hopefully this is making sense, and now we're going to pull this all together and actually do the math to answer this question. But before we do that, I'm going to ask you if you wouldn't mind subscribing to my channel. This really does help me. I wouldn't ask if it didn't mean that much, but really my objective is to help others. Okay, and the only way I can do that is if my YouTube channel continues to grow. So by you subscribing, it really does help me find other people like yourself that are either one, interested in math, or two, need assistance in mathematics. Either way, I want to be your, personal YouTube math teacher. And if you're going to do that, make sure to hit that notification button so you can get my latest videos. So thank you so much. And now let's get back to the problem. Okay, so here is the situation, but we're kind of distilling this down into a right triangle. Okay, so here's our triangle. The boat speed is 5, the current's speed is 5, and they're perpendicular to one another because east and south form that 90-degree angle, right? So the objective here is going to be to find the length of this part of this triangle, this side of the triangle, okay? If we can find the length here, that length represents the what? This is the actual speed, okay? Now, what is the direction? Let's just go ahead and answer this right now. So if we have a right triangle where the sides are the same, the only way you have that situation is in a 45 degree right triangle. Okay, so this angle right here is 45 degrees. So if you didn't know that, now you know this. And here, because this is a right triangle, in other words, we don't have a situation where the current is, say, going this direction, right? So if the current was going this direction, not, let's say, due south, then our resultant vector would be like this. That would call for more interesting math like the law of sines or the law of cosines. By the way, if you are interested in learning, a lot more about vectors and trigonometry and whatnot, check out my pre-calculus course. You'll find a link to it in the description of this video. Okay, but in this particular problem, this is actually quite easy. We're going to be using the Pythagorean theorem to figure this out. Okay, so the Pythagorean theorem is a squared plus b squared is equal to c squared. So this just relates the sides of a right triangle. Okay, now the sides here, these two shorter sides can be a and b, but the key here when you're using the Pythagorean theorem is that the longest side is always c. Okay, this is called the hypotenuse, and this is what we're looking for. Okay, we don't know what c is, but when you're using the Pythagorean theorem, the longest side is always the hypotenuse, okay, and that is the variable c. Okay, so let's go to just plug in this information. We have 5 squared, that's going to be a squared, plus b squared, which is going to be 5 squared as well, is equal to c squared. 5 squared is 25, plus 5 squared is 25. So 25 plus 25 is equal to c squared, so c squared is going to be equal to 50. So to solve for c, we simply have to take the square root of both sides, and c is going to be equal to approximately 7.07. Now, technically, this is a quadratic equation, so this would be a positive and negative value, but we could throw the negative root out because we are talking about distance here, right, or speed. So it's going to be a positive approximately 7.07, and that is our speed of this boat in knots, okay, which is nautical miles per hour. So boats and aircraft use knots, not miles per hour. Okay, so that is the speed. Now let's go ahead and put this all together and figure out the actual compass heading. All right, so we have, again, this right triangle. The sides are the same, so this is a 45 degree. Remember, the sum of the angles in a triangle is always 180 degrees. So we have the speed, which is 7.07 knots. So now let's think about it, okay? What's the actual heading of this boat? Well, here is north, here is due east. The boat was originally going due east, okay? And the current, it was going due south, which is 180 degrees. So the boat was originally trying to go 090 degrees, but because of our lovely current here pushing it, it put it off its course 45 degrees, right? So that its actual heading is going to be 90 degrees right here, right? That's where it was trying to go. But this 45 degrees is its actual direction. So 90 plus 45 is 135 degrees. That's the boat's actual direction at 7.07 knots. Okay, now hopefully most of you out there don't look like this. You're like, that was crazy. I got smoke coming out of my ears. Well, listen, I try to kind of break down a lot of principles here as easy as I could. But, hopefully the big picture here is the vectors, right? So when you hear, when you're watching a movie or you're watching TV and you hear this word vector, and you'll hear it, and once, now that you know it, listen for it. Anytime they're talking like aircraft or air traffic control or anything else, or they're directing airplanes, they'll say, hey, go, here is your vector. Go this speed and this direction. Okay, so that's the big picture idea. And vectors are tremendously important in mathematics, physics, science. They're used everywhere and obviously navigation as well. Okay, so hopefully you enjoyed this video or got something out of it. And if that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.